Okay, for this question, it's a topic of 9, that is the spatial distribution. Alright, all Penang Matriculation students sat for a special mathematics test. The mean and the standard deviation of the mark obtained by the student are 125, and I'll try to amend the question slightly, and is follow, or we say is normally distributed. Alright, so slightly change a bit, and this distribution is normally distributed. Find the number of the students from the random sample of 200 students who are expected to obtain not less than 80 marks but not more than 120 marks. Firstly, we need to define the x first, that the symbol that we are going to represent the random variable. So the x is normally distributed, where the mean is 100, and this we need to take a square because the figure given is a standard deviation. So the figure that we are going to write it down here is variance, so need to be square. Alright, so to get the number of the students from the random sample of 200 who are expected to obtain not less than 80 marks but not more than 120, first we need to get what is the probability not less than 80 but not more than 120 marks. So actually is not less than 80 is x greater or equals to 80, and x less than or equals to 120, which is means by not more than. So then we are going to find the intersection between these two, because here we have a intersection. Alright, so we can use a number line to help us. Since we want to find the intersection between these two intervals, actually is the intersection of the these two arrows, the overlapping. So we can see that this actually can be written as x is in between, or from 80 to 120. So to calculate the probability of this, firstly we need to standardize the x become the z. So we are using the formula to standardize, that is taking this x minus the mu divided by the standard deviation, that is 25. After simplify, we get the negative 0.8, okay, to 0.8. So try to sketch your bell shape to determine which is the region to get and figure out how you find from the table. So from the bell shape diagram, you can see that you are going to find the area in between negative 0.8 to 0.8. So by using the table, we need to modify to suit the table, that is using the 1 minus z greater than 0.8. So this area and this area, obviously they are the same. So we can actually put twice of the probability of z greater than 0.8. Get the value of the probability z greater than 0.8 from the table. That is 0.2119. Finally, simplify, we get 0.5762. And the question asking for, if let's say we got a 200 student sample, what is the probability to get a number of student that is having the marks from 80 to 120. So from this 200 sample, we multiply by 0.5762, we will get 115 students. So this is the estimation of the number of students. And come to the question B. If a 50 best student from this sample will be awarded prizes, find the minimum mark obtained by a student to be awarded the prize. So we set the probability for the x is greater or equals to the m. M is the marks, which is equivalent to the 50 student out of 200 students getting the prize. So the probability will be 50 over 200. And our purpose now is to get the value of the m. Firstly, we try to standardize first. So now you can see that after we standardize, still we have the term of containing the m over here. So I will sketch the bell shape to determine where is the region that I'm interested in. So this is a 0 in the middle, and the probability is 0.25. So m minus 100 over 25 will be located at the right hand side of the 0. From the table, I got the estimation. Pz greater than 0.67 equals to 0.2514, which is this is the nearest to the 0.25, the probability. So we can compare the m minus 100 over 25 to 0.67, and from here we can solve for the m, which is equivalent to 117 marks.